everyone, and welcome back to the Information Bottleneck. And today we have a great guest, Yaroslav. He's an AI researcher and early researcher at OpenAI and at Google Brain. He was one of the first to put production systems of deep learning and did a lot of other things in the last 20 years related to deep learning. So hi Yaroslav, nice to have you.
Likewise.
And as always, Ellen. Hi Ellen.
Nice to see you again, Ravid, and nice to meet you, Yaroslav. And you've already taught me something because I did not know properly what the Hessian was until I just chatted with you just now about that.
So today we are going to talk about a lot of different topics, but we will try to focus on why deep learning actually is not such a good idea. Like what are the places that deep learning is not working, and how can we try to propose different approaches and like different directions in order to get it better. So, Yaroslav, maybe we can start with AGI, a term that everyone are talking about it these days. So, what do you think about it, and what is the problem when everyone talking about it?
Right. So periodically, every time I come to a party in San Francisco, somebody tells me, when is AGI happening? What is my timeline? And actually, people ask me so much. I wrote an essay called God, Gold, and GPUs, and I just point them to an essay, but I can give a rough outline. So like modern AGI discourse, people think of it as kind of like a second coming of Christ. Like there's this point, like you go and things are hard, and suddenly AGI comes and things are great. There's this little book called Machines of Loving Grace. Actually, my friend of Anthropic, he brought it. It's like a little blue book. But it basically talks about all the great things that will happen after we get AGI. We will basically feel good. We won't have to work. Diseases will be cured. So it paints like a very optimistic, nice picture. I mean, maybe I'm just old. I'm kind of cynical that we'll have like this sharp transition point that we'll just have this in 3 years, things will be amazing, or in 10 years, things will be amazing. So I think the question is when AGI coming, it's more like a religious question. And I was raised in USSR. I'm not a religious person, so I kind of like don't think in those terms. I can't answer this question. When will be this point when everything will be amazing? There's a second
But
kind
do
of
you think?
yeah.
Do you think first, like, let's start from the beginning. Like, do you think like AGI is well defined term even? Like, what does it even mean, right? Like, a lot of people are thinking they know AGI, like what does it mean, but to get like a very concrete definition, it's quite hard.
Yeah. I think there's basically there's three kinds of AGI. So one, it's more like something amazing. So we can't define it, but we'll know it when we see it. So it's like the religious AGI. Then there's a second kind of AGI, which I call the account gap insurance. It's, I think, what's promoted by some of the companies whose financials don't balance. So essentially, if you actually do the math, if you look at some of these companies, how much they're spending, what they're projecting, in the end, things still don't balance. And they're saying, well, how will you make it balance? The answer is AGI. So it's like this extra thing that you put in to calm the skeptics. So as long as this logic works, then we have AGI. So right now, this account gap insurance argument still works. And the third kind, it's more like a feeling. So for instance, I tried Suno for the first time in December. I visited my parents in Oregon and I tried to get them on AI. My dad now uses Anti-Gravity. My mom uses Veo to generate videos. But I discovered Suno for myself. So first time trying Suno, I felt the AGI. I'm like, wow, I can be a music producer. This is amazing. So I think you hear people saying they're feeling the AGI. I feel the AGI sometimes. In that sense, AGI is already here, but it kind of depends on your mood. Today you feel the AGI, tomorrow you don't. It kind of changes from day to day.
Okay, I need to interject because you even quoted the title of the exact article by, I think, possibly a colleague of yours at Google. Peter Norvig, who
Mhm.
wrote that exact title. AGI is already here in Numina Mag back in right when ChatGPT came out, like late 2022 or early 2023. And I want to play defense of this idea. Also, I'm
Mhm.
from Oregon, and what I'm
Wow.
about to throw at you is definitely closest to that final "I'm feeling it" kind of argument. So I don't like this term AGI very much
Mhm.
either, because I think most people who say it in what even any of the three definitions you brought up really mean something closer to artificial general superintelligence,
Mhm.
right? But most humans, just going back for a moment, most humans are totally different in their skill set. Like from 5 humans across each other, they will have some skills that they might share a lot of similarity in, but
Mhm.
most skills they don't at all,
Yeah.
right? And so
Mhm.
humans, I claim, are a jagged frontier, which
Mhm.
means and so when we build a system that is very different from how it behaves to us, but is in general quite intelligent and very good at certain things that many humans aren't, I'm
Mhm.
willing to declare that that's a new type of life, kind of.
Mhm. Yeah.
And accept that it's really bad at spelling because of tokenization, for example,
Mhm.
in ways that we can explain. So I guess by this definition, I really defend Peter Norvig, and he makes all these arguments in his essay. But like, what's wrong with saying AGI was a really low bar and
Mhm.
accepting that most humans are stupid, so it's okay to declare AGI when things are stupid still?
Mhm. Yeah, I mean, for chess, for instance, chess was considered to be the benchmark of AGI until Deep Blue. And actually, I brought it up. My former advisor, Thomas Dietrich, he was on the AAAI committee, and he brought up that there was a debate after the chess. What does it mean? And actually dug up the discussions there in this essay, which I will link somewhere after this, God, Golden GPUs. But in the discussion, at least one person said the future is incredibly bright. We have the technology to create more sophisticated thinking machines, and soon 80% of the work may be automated. So in 1998, some people already felt the AGI, and they're like, it's already here. But this just underscores how difficult it is to just have a single benchmark, because we keep beating those benchmarks. Like Turing test, chess, ArcAGI is close to being solved. It's like, it's very hard to have like a single test.
But so I will claim. So we just published a paper, like an opinion paper with Jan and others that claim that like we don't need this definition. That like that people that actually humans, right? Like at the end, human intelligence is not general. Right, it's
Mhm.
very specific. So you need to talk about, like, when you want to talk about these kind of capabilities, like you need to talk about specializations, right? That like what is like for a specific type of thing, like what, like how can we, like how much we can adapt to this specific task, and not like we are good on all the I don't know, all the tasks in the world. This is kind of like, I don't know, no free lunch, right?
Mhm.
Like there is no meaning to talk about the generability in this
Mhm.
case.
Yeah, I guess you and I don't need it, but there are some companies which need it because there's no financial logic which makes their projection make sense.
So let me propose then. I've always considered the golden, the guiding star, because I think that's what we're all trying to talk about, is what is this thing that we're trying to build towards? And this is a religious argument, right? I always thought it was recursive self-improvement, RSI,
Okay.
right? And the paper that Ravid refers to maybe defines it with its own 4-letter acronym, which I cannot remember. Maybe it's 3-letter, which you should mention, or maybe I can dig it up in a moment. But
Mhm.
I
there's been
think we call it like, yeah, I think we call it like a specialized, superhuman adaptable intelligence.
yeah, and the adaptable part is, I think, where the RSI comes in, because
Mhm.
that's about incremental slash online learning, right? And Dario and other like CEOs of these firms have been debating about how important that is. And what's weird is a lot of them are saying, "Oh, we don't need continual learning,"
Mhm.
and I don't like that. I find that really scary, and maybe that makes me start questioning, can we hit will real RSI happen or not? Do you think any of this stuff matters? Or we spent too much time on this, like, at all?
You mean, does the definition matter or which part matters?
Yeah, the definition. Yeah.
I mean, it's a fun thing to talk about at parties. It matters to companies because how else will they justify their very large price to earnings ratios, or like how can they justify having negative cash flow for so long? So it matters for them. For me, it's basically a more, it's like a cultural. You can discuss culture, art, theater, literature. We can discuss AGI in the same manner.
Okay, so what is important? Like, let's talk about like, okay, so let's hope that the AGI, like, let's assume that AGI is not important. What do you think we should look when we try to develop better models, better systems?
Mm-hmm.
What are the important components or like the goals that we need to try to achieve?
Right. So right now, a lot of people around me, they're looking at capabilities, trying to do more and more things. And my goals are much more pedestrians. I'm actually right now very interested in taking existing capabilities and looking at ways of achieving the same capability much better. Because right now, the way, if you look at the progress of AI, it's been sort of like this evolutionary random walk. It started a long time ago on a different hardware without knowing where we're going. And in the last 50 years, we created like this big jumbled mess and things barely work. Like, I don't know, I was uh, at Archimedes Banya last Wednesday, and a friend of mine from OpenAI was outside in his car restarting a run because the run wouldn't launch. I mean, if you look at anybody who's training models, it is very human intensive. It's unpredictable. There's rumors that the GPT-5 didn't work well because they messed up hyperparameters. I don't know if it's true, but it's very believable. So, like modern AI systems, they're this extremely complicated systems which barely work, and the reasons for that is legacy. We never bother to kind of stop, take a breath, and maybe refactor the stack because everybody is super excited about the next thing. You know, can we get an extra percentage improvement on the benchmark? Is there going to be another new capability discovered? So everybody's like rushing in that direction, but I'm actually much more modest. I am simply looking at, can we take an existing application, which are already pretty cool? You know, we can generate songs, we can answer questions, and I am personally interested in making them much more efficient. And one motivation is I feel like because we never bothered to refactor, current usage of AI is extremely energy inefficient. It could be one, maybe even two orders of magnitude worse than it should be because we never cared about energy. We had the methods were designed by mathematicians who never actually bothered to look at, you know, the memory hierarchy of a GPU, and memory is where most of the energy takes place. So I'm actually looking at uh, tackling that aspect and making things energy efficient without sacrificing capabilities.
So what do you think about, and there were two paradoxes I wanted to ask you about, but one of them is this idea of Jevons paradox, which is that even if we gone up one or two orders of magnitude in efficiency, that people would rapidly consume it and start demanding even more of the very same system again because it's that much more useful to us in the world.
Right. So I can't control over how much energy people use in total. I can make AI more efficient, which you can either say you're reducing the joules per intelligence, or you can say you're increasing intelligence per joule. Those are two equivalent factors. And actually, if you look at the current projections, we're going to hit a power wall in 2 years. So right now, people are bottlenecked by GPU capacity. There are some hyperscalers which in 2 years, they expect to have more GPUs that they have power for because it takes so long to get power availability. So in that sense, in 2 years, we'll be bottlenecked by energy, and the only way to get more intelligence is to increase efficiency. And I'm just surprised nobody is really looking at that right now, but that's what I'm looking at right now.
But what does it mean in practice? Like, can you tell us like where, like, how to make it?
Yeah, so I have a very simple recipe. The recipe is we've invented AI once, and because it was invented in the open, we know how it was done. And it's basically, they call it graduate student descent. We have professors proposing ideas, students coming out, trying those ideas, the few ideas that work, you improve on them. So this process is completely transparent because it's been published. So right now what I'm doing, I'm just going back to the 60s and just replaying this process. And I had this original plan. Originally, I allocated, I'll spend 20 years replaying it with the benefit of hindsight, and then I'll retire and I'll spend 20 years teaching. But this year, agents came out, and I noticed that I am 100 times faster at trying ideas. So I'm like, I don't need 20 years anymore. So in practice, what it looks like, there's a few volunteers. I advertise on Twitter. Come join me. There's a few volunteers in San Francisco. So every Monday we get together. We practice reinventing AI using agents, share some tips, and right now it's completely in the open. So this is not a company, this is a community effort. Everybody should join it. If you hear this, you just look at my Twitter. I have some links.
But what do you want to do? Like, do you want to win on some benchmark, like to first to implement some ideas and then to try it in different scenarios? Like, how does it work?
Yeah, so I mean, on the board, what is my eventual goal? So my eventual goal, when I retire and teach, I don't want my lecture notes to be ugly. So I kind of want to make sure that AI is in a good state so I can teach it well. Like, I don't want to teach about prompt engineering, telling a model, I'll give it $5 if it gives the nice answer, because next year it may be $10. I don't know. So I kind of want to refactor it to be nice. But what it looks like is basically designing a series of toy tasks, practicing solving it using AI, and gradually make it more complicated. So for instance, right now we're looking at solving sparse parity task. So we have some simple baselines, a thing which solves sparse parity for 3 bits, something that measures approximately how much energy it uses. So now the task is, can we get AI agents to invent new algorithms that solve sparse parity while using less energy? So like the energy usage is the main thing that was neglected when inventing AI. So I kind of want to replay it, but always thinking about energy.
And the power consumption, that's one side, but you're also trying to talk about reducing the memory and hopefully
Because
storage capacity, right?
because these
I mean,
are extremely well connected. So for instance, one thing I did at OpenAI, I worked on gradient checkpointing, which reduces memory, but it actually also reduces energy use, because most of the energy used in modern AI training workloads is because of memory. So if you reduce peak memory, you will probably also reduce energy.
So what do you think about existing methods that are being kind of used to optimize everything? So I'll just point out, like, NVIDIA's started really focusing on low precision, like floating point compute, right? Going down even as low as 1.58 bits, or probably
Mhm.
lower now, log 3.
Yeah.
And that seems to be something that the architectures are kind of moving in lockstep with, right? Moving to sparse MOEs, multi-token prediction, auxiliary load free balancing for the experts, and more, right? So maybe I will point out that stuff is all well better than prompt engineering and bargaining with
Right.
$10. So I guess what's wrong, like I see the desire to throw everything out and start again from
Mhm.
new and see what
Mhm.
happens, but
Yeah.
what's wrong with just optimizing the techniques we have now that
Mhm.
they're starting to move in lockstep with each other a little bit?
Right. So the question becomes, can you take an existing complicated things and optimize away the inefficiencies? Um, maybe not. So there's some counterexamples. For instance, an example from biology. Have you heard of the recurrent laryngeal nerve? Well, so you can look it up, but basically there's this nerve which goes from our brain to the heart and then back to our larynx. And in giraffes, it makes it extremely long. And the reason is that uh, in fishes, it was a direct connection, but somehow it was routed on the other side of the heart. So when the neck grew longer, it became extremely long. So if you're faced with the situation and you want to fix the problem of the long nerve, you may respond by making the neck shorter, but that has downsides. So the way I see when people are trying to adjust to this algorithms, it's sort of like this making the neck shorter. And a more related example is Python global interpreter lock. So Python was, designed in the 80s with a single core. In 2006, we started to get multi-core systems, and people thought, oh, we should probably refactor Python to be suitable to multi-core. And it's been 20 years, and the last I heard, it's close to being done. So meanwhile, we created these workarounds. So if you run Python, it's actually probably going to most of the time use most of the cores. We move the stuff to CPython. So the way I look at current workarounds, they're sort of these hacks to get around the fact that the underlying algorithm was designed for CPUs. And the underlying algorithm is, well, gradient descent is inherently sequential. It's serialized. Layers in neural networks, you have to compute one layer after another. There's like many of those examples of global interpreter locks, which are present because we designed these algorithms for CPUs, and we are creating workarounds. And I'm looking at just doing a blank slate redesign.
What do you think
But
that design looks like?
What do I think? What?
The design looks like? Like, what does it look like? The new.
Right. So that's kind of like the outcome of this effort. I know what the process looks like. The process is just to do whatever we did, just repeat the process of the last 50 years, but use the benefit of hindsight. But if I were to guess, I might imagine it may look more like message passing, because if you look at the architecture of modern GPUs, you have, H100, you have 132 streaming multiprocessor. Each streaming multiprocessor has 128 cores. And, there's fast memory where the cores can exchange messages with each other every 30 clock cycles, but HBM takes like 500 clock cycles. So you should probably do 30 flops per each access of a shared memory, and maybe you should do 500 flops per each access of the HBM, which suggests some kind of a local hierarchical message passing algorithm.
But you don't afraid that, like, at the end, current deep learning, like, I don't know, 10 of thousands or like even more people worked on it and optimized it over the years, right? And it's kind of like, as you say, like gradient descent of a lot of different ideas from different people in different scenarios that like with a lot of compute, right? Do you think it's reasonable to believe that we can replicate it, that like you can replicate it in, I don't know, even if you have like hundreds of people,
Mhm.
right?
Uh,
Do you
I mean,
think this
most
is something that
yeah, I mean, most of the ideas of deep learning were already settled like in the 80s. And if you look at the amount of compute people at the time and number of people that were involved, it was not that many. I mean, in the last few years, there's an explosion of people, but they haven't really changed much of the underlying algorithms.
but at the end you have a lot of ideas, and in order to understand or to make sure which one is better, like you need to, right, like you need a lot of engineering tricks and you need a lot of compute, right? Like we had these ideas from the 80s, but still there were a lot of ideas and we didn't know which one will work, right, till like
Well, I mean, Jan
2010.
LeCun invented his things using Spark 7, which is a lot less powerful than an iPhone. So I think if Jan LeCun could do it with a small amount of compute, then I could also do it with small amount of compute.
Well, so this was, I mean, I'm sure he understood the hardware he was working with at an intimate level in a way that I think maybe you're lucky enough to have computer scientists working with you who also learn that even for modern hardware. But that's a surprisingly rare thing, even in good programs these days.
Well, I think a couple of years ago that's the case, but now I think because of AI, it's been normalized. So right now we have people in our group. There's like a sales guy who's one of the most productive people. He had no background in this, but he used AI to get himself up. So I think in the last couple of years, the gap between experts and non-expert has shrunk. And in fact, I'm finding maybe experts are actually a negative value because they're very attached to their ideas. There's this old quote from a speech recognition group by, I think, Peter Jelinek. He said, every time I fire a linguist, my accuracy improves. And I'm finding a similar idea where non-experts are actually more open to trying these ideas and learning about them, whereas the experts are like continuing to try their ideas. So I have a personal experience. I was really into optimization. So I spent several years trying hard to get second order methods to work. Um, and I realized it's a bad idea, but some of the people I worked with, they continue trying and they may try for another 10 years. So I actually like non-expert because they're more flexible and they're more like pragmatic. They just see what works and they go with it. Whereas some of the experts, they're like, they pick it and they're ready to go for 10 years without seeing any results.
So you really care about maximizing the diversity of ideas that are explored, right?
Yeah.
That seems like a big theme for you and what you're focusing on, right?
Yep.
So, what do you think? Like, okay, so what do you think will be like a good, like, how you choose the right direction, right? Like now you have a lot of different ideas in a lot of different directions, right? Some of them we may have better like performance, some of them will have like better like efficiency or whatever. Like how you choose the one that now you want to say, okay, so now I am going to use like how many GPUs that I have in order to check if this is actually works in practice on like
Yeah.
problems that people like using in day-to-day life.
Right. So this would be a hard question to answer 20 years ago, but luckily today we can use the benefit of hindsight. So we can look at what happened at OpenAI, uh, ChatGPT 2. Like, why does ChatGPT have such a bad name? People actually didn't expect it to be so powerful. It was obviously an experiment. So what happened is Alec Radford trained a model for next character prediction, and an unexpected side effect, this system somehow captured human reasoning. So I'm sort of motivated by this to try to do the same thing. So I think a final useful sanity check would be to take a system which can do Wikitext 102. So just take 100 million characters of training data and then 1,000 characters of a question and then produce one character answer. And that would be like the benchmark to go towards to do this in an energy efficient way without sacrificing accuracy or wall clock time. So whenever I'm designing toy tasks, I'm always keeping that task in mind because that would be like the final validation. Do we get something that's as good as GPT-2 without sacrificing accuracy while being much more energy efficient? And once we can show that, that opens up the next, the next stage of exploration where we can, use much more resources for the next stage.
And do you think this is like all the ideas will have these scaling laws, like the same scaling laws that like if something is beating GPT-2 size, it will work better on like larger
Um,
models?
yeah, that's the assumption I'm going with. If we can do GPT-2 without sacrificing accuracy, but improving energy efficiency, then this will be an argument to get much more resources and go much further with this.
So you seem really well connected to so many of the folks who've built the current world we're in. And I'm just I've never gotten to meet some of them personally, or in some cases I've only spoken to them very briefly. I'm familiar with you said Ian Goodfellow, right?
Yeah, well, he was my intern, yes.
Yeah, yeah. So what do you think of Keras and Ian's work and his projects and everything?
Well, Kara, I'm not sure. Did he do Keras? So he did Theano. So Theano is what.
Getting it all mixed up. Gosh,
Yeah, no
darn.
worries, no worries. So he did Theano, and actually Theano was a big, huge inspiration for TensorFlow. Um, I remember in Theano, it was a graph-based system, and it was quite slow. So the graph compilation step was slow. And when we were at Google Brain, he kept bringing it up. It's so slow. So Jeff Dean, whenever he would commit a change to the initial TensorFlow system, he would always benchmark the graph compilation step, and the time was like microsecond. Whereas Theano, so the complaint was sometimes it took 8 hours to compile the graph. So in that sense, yeah, so it was an inspiration for TensorFlow. What do I think about? I think he worked on some fusion stuff, and he left Google not so long ago. I think he was excited about coding agents, so he may be like exploring in that area right now.
And what do you think, like, if you need to, like, kind of compare between good ideas, like how to create good ideas, like, okay, you said it, like, we know the recipe, But do you think like the level of people, like the how people, like, I don't know, how much they are like smart, or like, I don't know, the interaction in the team, or like the infrastructure that they have, like, what do you think are the most important parts in order to build better models?
Right. So I see there's a lot of selection bias. There's a few people that got on a good idea randomly, and then people retrospectively glorify them for it. And I actually have the opposite view. And I have two experiences which shaped this. So one experience, couple of years ago, I was at a company. They got really excited about AGI and convinced a rich funder to spend $1 billion on GPUs. But then it took longer than I expected to get it working. So I was there, we were sitting on all these GPUs, and I was handing out the GPU boxes to random people on Twitter. And one of those people was Keller Jordan. And my only condition is do whatever you want, but if you find something cool, you have to tell me. And he used it to iterate on CFAR. He had like this 2-second CFAR, and he discovered Muon optimizer. And I think that's an example where being an expert is counterproductive, because optimization people try to improve on Adam for 10 years with little success. And Muon is just such a weird idea that no optimization person would try it. It was completely like outside of their scope. But Keller Jordan is not an optimization person, so he was not prevented from trying it. So he tried it, it worked, he published a blog post, and then he moved on. And now we have optimization people coming in and said, aha, we knew it. It is spectral descent under, or its steepest descent under spectral norm. So now people are writing papers and explaining it, but it's retroactive. I think for doing something new, it's, you just have to try many things. I think the most important is like curiosity and fast iteration. And the second example which guides me, there's a point after I left Google Brain that I got interested in this competition on benchmark. And it's basically who can train ImageNet to 75% accuracy without any limit on amount of compute used. And at the time, Google had the #1 spot. It was like 22 minutes. And I basically took 100,000 of AWS credits. I spent 3 months creating infrastructure to rapidly iterate. And then I got this bright student from Fast AI, Andrew Shaw, who was a mobile developer. And he took 3 months of Jeremy Howard's class. And then he started iterating. And after like a month, he was already better than me. He discovered this better batch norm initialization scheme, which actually gave us the last 2 minutes to shave off the time and beat Google. So now there's like this article in MIT Technology Review. It's like a bunch of students beat Google. But these two experiences make me really bullish on non-experts. I think you just need to be, focused, iterate fast, and be pragmatic. You need to look at whether your thing works and brings some signal.
And do you think, like, is it better to work in a team?
I think
And what side of the team?
Yeah, I mean, I think team helps you. One, we're humans, we get motivated when we're around other humans. You get better ideas. You may like get stuck on something, a person can see it and it's like, oh, why don't you try this? Yeah, I think there's some rules, like more than 20 doesn't work. I kind of like small teams, just, at least 2 people, at most 5 to 10 people. I'm trying to right now to do this effort in a distributed way. I'm kind of inspired by GPU mode. So Mark Sorafim was able to grow to 25,000 people. So that's like an alternative approach, which is exciting to me because I think 25,000 people armed with ChatGPT or Claude is almost like having 25,000 Jeffrey Hintons in my mind. And I think they can do a lot. How to organize it, I'm still learning that.
So you mentioned earlier, since we've been throwing around so many famous names, kind of an idea that I opens like, what do you think of Schmidhuber? Jürgen, I think is his first name. Please correct me. He'd probably be mad for me.
Jürgen Schmidhuber. Yeah. So actually, yeah, I talked with Navdeep Jetli yesterday. I'm trying to talk to everybody who was among the first to use GPUs for deep learning, and I'll write a blog post. So I talked to Ian. According to Andrew Ng, he's the first person to use GPUs for deep learning. Navdeep was the first person to use GPUs for speech. And I talked to him, and he told me to be careful. I should check Jürgen Schmidhuber because he might also be the first. I mean, he has good results, good papers. I liked his work. Original. He had the state of the art on the MNIST with elastic deformations. His work with Sirisan. Um, yeah, so he's old. I believe he's one of the pioneers. So I respect his work.
Well, me too. It's fascinating that he had to, he has a reputation for asserting himself, as I would call it. What's
Yeah.
fascinating is when people go and fact check him, they mostly agree. It's like actually he's right,
Mhm.
right? Like, and it tends. I kind of do you think that it's so-called some outside observers might write it off as cockiness? Do you think that that kind of attitude is okay, even if you're right? I mean, I do,
Mhm.
right? But I think it leaves him as somebody who's considered a bit contentious in the field, right?
I mean, yeah, it became a bit of a meme. Maybe sometimes it's nice to have some contention. It makes things fun. Um, I also think he's like the most physically fit AI researcher. Like there's some topless photos of him, and I I think that's nice to take care of your physical health. Yeah,
Have you seen the OpenClaw creator? Have you seen the pictures of him? He is jacked. Oh
really.
my god. He steals your vibes and then
Uh-huh.
steals your girl.
Wow. Okay, I definitely support taking care of your physical health. So this is a good role model to follow.
I have a question. So, what do you think about like you mentioned before that we need the fast iterations? What do you think about okay, two questions. One is like AI coding agents in general. Software engineers think they will disappear, like these types of or this kind of work. And the second one is what do you think specifically on research, like
Mhm.
coding agents and coding models for research? Because it looked that in the recent weeks, kind of like there is a lot of excitement about it, and it looked that they finally can, close the loop of making experiments by themselves, look on the behavior, look on the results, and like improve some of the, I don't know, hyperparameters and like try new things. What do you think about it? Do you think like this is the future, or are they good enough already? Do you think you like we'll see this is something that you'll see more and more?
Mhm. Yeah, I don't think software engineers and researchers would disappear because if um, a software engineer can do 10 times more stuff with agents, people will expect them to produce 10 times more stuff because we don't have like a fixed amount of stuff we need to produce. Like originally, people worked to produce food, but now only 5% of Americans are involved in farming. And the 95%, what are they doing? It's the things we didn't know we wanted. Like maybe somebody works at a car factory. 500 years ago, we didn't know we wanted cars. We wanted horses. And 10,000 years ago, we didn't know we wanted horses. We were fine working everywhere. So what happens is every time we increase our efficiency, we also increase our demands. Maybe in 100 years, it's not enough to go to Mars. We need to go to Alpha Centauri. So the demands are always raising. So I don't actually expect people to be replaced. But definitely it's already become an inherent part of the workflow. For instance, I have a friend in Google, and she said that 8 months ago, she tried AI coding agents for the first time. And last month, Gemini was down and nobody could do any work. So this seems to be the fastest technological transition in history, like 8 months from zero to like impossible to work without it. And the AI agents for research, it's not as mature. So for instance, one contributor to our group, they have this automated Claude agent to try to improve learning algorithms, and it made some experiments, and all of the proposed ideas were worse on all axes. It's like slower, worse accuracy, and worse energy. So we still need to like figure out how to make agents which are as good as like an undergrad. But I think we're getting there. I think we'll soon be at a point where we can like people can work as professors and they have like a bunch of undergrads running around trying experiments, and you just look at the results and you guide them. I think we're pretty close to that point.
And what do you think? Do you think this is something that you will try, personally to
Yes.
push in these directions?
Yeah, I definitely want to push in that direction. I'm hoping I will nerd snipe somebody to figure out how to do it because things are changing so fast. Like somebody is telling me I should do OpenClaw. I haven't looked at it yet. So like every month there's some new technology that's changing. So I'm hoping like to uh, collect people together who will like collaboratively figure out the techniques they would do it, because I think that's the advantage. That's how we make this research take less than 50 years. Like I want to go back to 1960 and replay the last 70 years, but I don't want it to take 70 years. So I think this is the factor which makes it possible.
And what do you think will be the results like in 10 years from now?
The
Do you
result.
think like what is your time scale basically?
Mm-hmm. Time scale for my project or for AI in general?
Both.
Um, I mean, for my project, I guess the best case scenario is in 2 years, we'll have proof of concept, which takes 100 times less energy to get the same results for next character prediction. Maybe more realistic is 10 times less energy, based on the fact that right now we rely on HBM, which is 100 times more expensive than registers, but shared memory is only 10 times more expensive. So if you reduce your memory accesses to be just one level of hierarchy lower, you will get 10 times reduction in your memory energy cost, which is the main cost of AI training. And as far as what will society look like, maybe we'll just have we'll still be working the same amount of hours, but instead of typing in editors, we'll be prompting AI agents, or maybe we'll be talking. Actually, you see this microphone right now. I do most of my vibe coding using voice because you can speak so much faster than you can type.
Yeah, and I'm glad you do that. I actually do that now too for a lot of my workflow, but I want to give another advantage to speaking, because if you a lot of people handwrite or even try to do lightweight prompt optimization and write out prompts that they try to optimize before using it on a task.
Mhm.
But AI has serious slop problems, referring to overrepresented words and phrases that reduce the diversity of the possible outputs.
Mhm.
And while people are influenced by all the AI stuff they read in interpersonal communication, there's a paper on that.
Mhm.
Being able to say things out loud, you keep more of your voice in your writing style than you do when you type, at least for me.
Mm. Yeah, sometimes I would use AI for uh, proofreading my tweets, but it actually makes them too verbose. So often I just reject the suggestion.
What do you think about multimodality? Like you mentioned at the beginning that you are focusing on text.
Mhm.
Um, do you think this is something that like first of all why, and second of all, like do you think this is something that it's worth to combine with other modalities, or do you think there is something specific in text?
Um, yeah, so I'm focusing on text because it's the lowest hanging fruit. The data sets are small. Wiki text 1 or 2 is like 100 megabytes. So, and it's also like a necessary prerequisite. Like if you can't make it work on text, there's no hope to make it work on multimodal. Um, so I kind of want to start with the simplest things possible. So text is just the simplest thing.
Why? Why like this is I don't know if you can make it work on text you can't in other domains. Why is the case?
If I can't make it work on text, well, it's like if it's similar to why would you start with MNIST? And the heuristic I use, if I can't make my optimizer work on MNIST, I shouldn't bother trying to make it work on a larger example. That's just a heuristic that worked for me. Your thing needs to work on a simpler task first. So I just don't have hope that something that fails to work on a text, the same technique will work on a larger task. It's just too expensive to try.
Do you think that like I don't know there are like smaller size data sets for vision for example, right?
Mhm. Yeah, I guess the second reason text impact is much larger. If I have a simple task, there's already a lot of application for text completion, whereas multimodal, it's not as direct. So I would have less of an impact initially. So basically, it's like effort to reward ratio is much better for text than for other domains.
And do you think like the ideas like the process will be similar like just for other domains? I mean, like do you think this is like we can just replicate the same process, but this is just matter of like resources, or there is something fundamental different there?
Yeah, I think it would be replicating the same process. The idea is to figure out the process of inventing AI. Like it could be an agent, but it could be just a bunch of Google Docs describing what we did. So If it works for text, then we just say, well, here the starting point, just replace this again, replay the whole thing again for multimodal and maybe improve on it.
And how much you think you need domain expertise?
I think I need very little domain expertise because it's one question away. We just, uh, and it's better because, yeah, I think because of AI, we remove the need to actually have domain experts.
And do you think this is like, do you think like people will like, for example, all these companies that like the AI labs, right? Like Ilya's company or
Mm,
like whatever, thinking machines. Do you think they are in the right direction and they are trying new things, and or you think they basically do the same thing and don't have a chance to real innovation or like
yeah.
real progress?
Yeah. So I think there is a tendency for everybody to chase the same peak. So that's one problem. And the second problem is um, domain experts are very incentivized to convince everybody that domain experts are important. So they're kind of attached to this. So whenever you come to a company with a lot of domain experts, they'll kind of continue the status quo. So looking what SSI is doing, I actually don't like the secrecy, like the approach they're taking there. And I think it sets a bad example to junior researchers. So a new researcher coming out into the field and they look at it like, oh, SSI is so cool, and they do everything in extremely secretive way. Like it's so secretive. There's like rumors you cannot have a partner in a competing AGI lab because they want to contain that information. So I'm kind of hoping to set the opposite example that you can do progress by being extremely transparent and hoping to, by achieving better results than them, this will kind of this will inspire the new generation of researchers to actually go the transparent and open approach and not this super secret approach that Ilya is taking.
There's a quote that I'm reminded of by George Bernard Shaw. The reasonable man adopts himself to the world. The unreasonable one persists in trying to adopt the world to himself.
Hmm.
Therefore, all progress depends on the unreasonable man. I kind of feel like a lot of the proposals that you're talking about and that we've kind of gone around are people who do not accept a status quo,
Hmm.
right? And push the world to move in ways that orthodoxy seems to disagree with. And I think that there's also in the philosophy of science, right? Karl Popper, I think, and structure of scientific revolutions starts trying to analyze, and also his student Paul Feyerabend starts trying to analyze why it was that like it was so difficult to get people to accept like the Catholic Church in the 1500s, or that the world's round and
Yeah.
all these other things, right? So uh,
Yeah. So I think there's a lot of tendency for people who developed a particular technique to keep promoting the technique. So with all due respect to Jan LeCun, but he, as the inventor of backpropagation, he would be very personally attached to backpropagation. So I think there's this public argument with me and Jan LeCun, like, will backpropagation be there in 5 years? And I was posting it wouldn't be, based on my observation of how it was invented. It was invented for the wrong kind of hardware. And this step of sequential step and saving all the activation, it just doesn't make sense for GPUs. And because we're hitting an energy bottleneck in 2 years, I don't expect us to be able to continue improving on AI without getting rid of that particular method.
Are there any methods or like I don't know architectures that you really like that you think will be fundamental, or do you say, oh, I don't know what will be? We'll see. We'll iterate and we'll figure it out. Is something that like, as I don't know, Jan likes a backprop or like world models. Do you have some concept that you think
Uh,
um
yeah, I
will
think
be there?
actually, yeah, I think nothing is fundamental. In fact, maybe I would go as further away. I don't just want to get rid of backprop. Maybe I want to get rid of math as the concept we use for inventing these algorithms. Because if you think about it, when researchers were inventing these methods, they were optimizing for beauty. And it used to make sense because you want your implementation to be beautiful meaning small, so you can communicate it to other people. And so this way, like backprop is standardized. You can just say backprop, everybody knows what it means. But maybe we're approaching a world where AI agent can quickly invent a new algorithm which is specialized to a specific task, specialized to a specific hardware, and maybe this algorithm will be too complicated for people to understand. So we could be approaching an era where algorithms will be like binary code. Like people used to write binary 70 years ago, but now they don't. But we build tools around it. So maybe we'll actually get algorithms which people don't actually study, but we have tools around. And the advantage of that could be is that this beauty is a constraint, but if we relax the constraint, maybe we're gonna optimize things better. And here, I want to relax all constraint possible in order to maximize energy efficiency.
And do you think like it will be possible in the sense that it's kind of like no free lunch, right? Like if you don't have any constraints, then you will search and search, but it may be that you will not find any optimal solution.
hmm I mean, it is true that representation is important. So you can't just tell an agent, give it a binary of a learning algorithm and tell it to modify random bits. That will be inefficient. So I think you do need some degree of beauty. And I'm still trying to figure out how much beauty do you need in your algorithms.
So do you think for like math there is no um rule for math, like there is no place for math, we don't need math anymore, we can just optimize the different methods, optimize the different architecture, and see what works the best? Do you think like we basically need to ignore all these
Yeah. Yeah. I mean,
equations?
so yeah, because representation matters during search, there is probably, you do need some idea of simplicity because the atoms, which things do you try? You can't just try random things. So there probably is some place for math. I'm still like trying to figure out how much can I get away with. Can I just not have any constraints and have agent optimize it? Ideally, yes, but maybe I won't, and I will have to actually combine it with some ideas to try. Right now, it's good that we have all these papers, so we can basically ask agents to like look at different papers, implement them, and have humans as a kind of like a guiding mechanism. But also math in general, um, there's a place for math in a society. It's entertaining. So I went to MAA last year, and Terry Tao gave a talk on prime numbers, and I remember being extremely entertained, even though I don't have a background in prime numbers. I don't need it for my job, but it was a very nice talk. So I feel like we'll still have math, we'll still have AI research, but we will not be forced to make it useful. We will just do it for fun, just like people play chess for fun.
Well, I think chess has a unique aspect where before we had the Deep Blue moment, and really 10 years after that, you couldn't have the commentators in a game of the two best grandmasters in the world be able to give even decent analysis, really. I mean, unless you had like the number 3 and number 4 commenting, which often they were practicing, right? But now, since then, we have, super intelligence that can rate who is better in
Mhm,
these competitions highly accurately.
mhm.
And so do you think that that's the aspect that makes humans still want to do things, is that we can still be, able to rank ourselves even in a world where machines have beaten us at most tasks?
I mean, maybe in some areas, but I think in math, people do not pretend math is useful and they still have fun doing it, like pure mathematics. I was just at the conference last week, Gathering for Gardner. It's the recreational math conference, and people have a lot of fun there. And I think maybe soon all math will be recreational fun, math.
And what do you think in general about the academia uh, in machine learning? Do you think we still need it to make progress, or if everything is empirical, so
hmm
probably I don't know, startups can do it better?
yeah, I mean, academia is great. For this unencumbered generating new ideas. It can generate beautiful field which will motivate more people to join in and have some results which eventually become useful. I feel like in machine learning there's so much money in machine learning that academia have been like a little bit corrupted by that. There was a discussion at NeurIPS last year. One of the professors said he doesn't tell people to research X and Y because it will make them less employable. So people are guiding their students to do things which are actually have more hands-on practical impact. So I think I don't really like this direction. There's already enough people doing practical things in companies. Do we really need everybody in academia to do those things as well? I think academia I'd rather see it more the way it was before the latest deep learning revolution. Just be there to kind of generate new ideas that can like create new fields.
Well, and it really does feel like business has gotten very deep into this one part of academia, right? Machine learning and AI. I mean, I've heard how people talked about NeurIPS 10 and even more years ago, back when it was still called NIPS. And today it feels like a business conference that the AI people just kind of have a side thing at. With
Yeah.
every 5 people you talk to, 3 of them at least are not people with papers, even at workshops, in my experience.
Oh yeah, and also last NeurIPS, I had a paper which was rejected, and then I learned that there are 60 high schoolers which had their papers accepted. And an interesting thing with NeurIPS, if you submit a paper, you're required to be a reviewer. So there's like a lot of high schoolers both submitting and reviewing papers. And actually, one of the underlying driving forces is that Stanford admissions are very competitive. So there's actually services you can pay somebody to coach your child to go through this whole NeurIPS submission process. So I think that's an example of Goodhart's law. Like when Stanford optimizes for NeurIPS acceptances, that's going to force NeurIPS to be a bad metric of success.
Okay. Yeah, we are almost out of time. Is there anything else that you want to add, that you want to talk about,
No, I think this covered everything I wanted to say.
that you want to promote?
Yeah, so I want to promote this effort. It's on my Twitter, Sutra group. We have like a challenge. Please look at it. Right now, we're trying to see if we can invent a better learning algorithm for sparse parity task. And there's a baseline using transformer, but I think it can be improved at least 1,000 times. We just need to figure out the right prompt to use to improve it.
Okay. Yeah. So good luck with that. Yaroslav, thank you so much that you joined us today. It was
Great.
really a pleasure.
Likewise.
And thank you, Ellen.
Yeah, always a pleasure, and I learned so much today, including the importance of the diagonal of the Hessian.
Very important.
Yeah. So thank you, everyone, and see you next time.
Okay, bye.